Hello, welcome to MyWebUniversity free educational videos. Today we're going to just go on chapter 4 of my book, The Direct Path to Linux Ubuntu. And this is Learning Linux Operating System Advanced Level. And we're on chapter 4, which is discussing advanced level. And on that chapter 4, basically, so far we have covered each of these topics that are here. The first 4 rows, which are about 44 commands with a lot of examples. Tonight, I'm going to cover a section, I'm going to cover the 11 commands on row 5, which is start with the stats and then finish with swapon. So I'm going to cover those ones with a little bit more details, and sometimes a little bit faster because there's a lot to cover. And I don't want to bore you, but I want to just give you the idea that you can just do any work as you wish and enhance your career. And that's my job, basically, to help you out to succeed in your career. I hope you enjoyed these videos. Please make sure that you subscribe to our channel. My YouTube channel is MyWebUniversity Free Education Videos. And I have a lot of videos that you can watch on C, C++, Python, installation, configurations of a VirtualBox, software, Windows related stuff, PowerShell, command lines, syntax with Linux, Bash, scripting, Apache web server, MySQL, you can name it. We are discussing everything that can benefit you at work or school. I hope you all love it and enjoy it and learn from it. So let's go back to chapter 4, and I'm going to cover starting with stats. In order to do that one, let me just go to my Ubuntu connection that I connected to my actual web server already. So from the Ubuntu, I set up this Ubuntu Linux 22.04 long-term support. As you can see the title, basically it's running and I'm connected as a virtual machine on top of this Windows machine. So this terminal, I set it up just to write this script to welcome you to my MyWebUniversity free education videos. And if I press enter, basically it's going to say please subscribe at our YouTube channel, and the URL is provided here. The URL is the same URL that I just showed you here. So when you go there, watch any videos, you're welcome to subscribe. And let me just come back here. And I really appreciate your subscription, because that would tell me how many users are eager to learn in the environment to succeed in the society. By you supporting yourself and your family in the society, we all have a great love and peaceful society. We all need to just help each other. So on chapter 4, there's the what is section for each command, the manual pages, and the examples. Let's just go to the stat. I'm gonna just make this screen a little bit more bigger. That way you can just see these commands. So I'm going to go to this section. And actually on the videos, you can also go to the chapter 4 videos, or just to the YouTube to watch these videos as I post them. So if I go to stat, the stat command is showing that it gets statistics about the commands. So let's just demonstrate that one. And then the man pages basically tells you the manual pages, which I wrote this Python program to generate the manual pages for you. So when you do a man stat, it will tell you that display files and statistics about the files. So any files that you want to get statistics about it, about the modification time, the creation time, timestamp, and the ownership and everything, all of that information is on that stat function, which the program command is also on Linux, is called stat. So let me just go to this interface and minimize this other one for now, and then just go to this interface here. So now if I just do where I'm there on this one, if I just create a file, say let's say ls-l greater sign new file.txt. I just create a new file.txt, and if I just do ls-l on new file.txt, you can see that the file and just got created as with timestamp of today. So the date currently is 12th of July, and it's 2:28 Eastern time a.m. in the morning, which is 11:28 Pacific Standard Time in California. So I'm going to basically do a stat on this file, stat on the new file.txt. And we could see that the statistics are shown up here. This was my command, stats new file.txt. And then the output is just basically, it shows me the inode number, and the links, the number of links that were there. These are the number of links here. And then the user ID, which is wlutfi, and the wlutfi is right here, the user ID here, and here is the user ID. And then group ID is also wlutfi, so you can see here. And then the time creation of access, when this file was accessed, the permission is read, write, read, write, read, which is the same permission here. And then the access modification, the timestamp. So any file that you do, you don't have to create a file. You could just make a directory, say make dir, new dir. And then now I created the new dir already existed. So I don't have to create a new dir. If I do ls-l new dir, notice that timestamp, sorry, ls-l d and new dir. So if I just do that one, you can see that that new dir is there, and the stat on the new dir will reveal the same kind of information, that this was ls-l new dir, and then the ownership, group ID, everything is all there, and then the access modification, timestamp information, and window was, and if there was any change was made, is there. So it's statistics about the file, when the file was created, when was modified, when was changed, and what is the ownership, the group ID, how many number of links are in the directory, or how many links is the files, if there's any symbolic link, all of that. Since this one is a directory, it tells you because of this D here. And this one was a file, and because of that dash there. So let me just go up a little bit here. And this dash, meaning it's a regular file here. And that's why it shows a regular file. The original path, it shows that on the inode structure, it has all these details about the timestamps that the file was created, and changed, modified, user, who owns it, all that details are there. It's read from this structure called inode. So let's just go to the next command. Going back here, and then we finished the stat. Let's just go to the next command and find out what is the next command. The next command is pldd. Pldd is just basically printing the process, including the object and then the link libraries. The dynamic link library, this LDD is basically the LDD command itself versus pldd. LDD followed by a name of the shared object file, it will just print out the list of dynamic link libraries. But when you do a pldd, you have to have a process, not a file. It does a process for the process. And then here I'm just showing you a lot of the examples on the process that I'm doing here. So if I just do a piece of this process, and then I can do a pldd on it, and the output is shown here. So if you just want to do any process, you can check it, and also you can do a man pages on the pldd, and then just get the output of it on my website as well. So pldd is displays dynamic shared object link on a process, not on a file. LDD is on a file, pldd is on a process. So what is dynamic link library? If you know Windows, all those .dll is the basically dynamic link libraries. If you are familiar with Linux and Unix, .so, the shared object files are dynamic link libraries. So if I just go here on my, sorry, not PyCharm, let me just click on this other one. When PyCharm comes in, I will just close it again. So here, if I go to my system here, and I go to programs, let's say I go on programs, and then I say, if I just do cd to, let's see if I have any binary files here. Yeah, I have it in C++. So I'm going to cd to C++ directory here, and then ls -l, and then let's say the hello.c++. So file hello itself is just a simple program to just print out the hello, right? So if I just do this hello and then run it, and you can see that it says hello world, welcome to MyWebUniversity. But it is a 64-bit shared object file, and it's dynamically linked. So if I do LDD on this one, LDD meaning showing me all the shared object files that it says here that it is linked, then it says, okay, this linked with this one, the standard C library, GCC, libc, libmat, and so on. So all of that on the loader, the Linux loader. So it's showing you that all the shared object files that are there. But if I just want to know that, for example, which node, if I want to know a binary called a node, this which node is going to tell me that is that file. I can also do LDD on that binary to see what is the shared object of that file. So then I could just, and instead of copying that file, I can do this command with $, left parentheses, like starting it, and then write the which node command here, and that will get executed, and then the output will be given to LDD, and LDD will just list all the shared object. I can also do the same thing with LDD with backtick, and instead of the $ thing, I can type in the backtick and then the command node. That would just give me the shared object of that. So now this is there, but what is the process ID of the system D? Well, for example, the process ID of system D is 1. So if I say ps -efa grep -I system, sorry, it is just ps-efa and then grep -I. The connection is a little bit slow, so bear with me. Ps -efa grep -I, and then I need to just do a system D. And as you can see, the process ID of the system D is actually 1, but I did not type in system D correctly. I type in 2 T's. Because of the slowness, I did not see it. System D, now you can see process ID of that one is 1. The main process ID of this 1. So I could say PLDD1, just to say that show me the system related process ID for the process ID 1, but then the LDD, dynamic link library of the process ID 1, but it's not showing me because I'm not root. So what I could do is just say PS, and then let's see if I can just get for my bash itself, because that is the shell that I started. So I could say PLDD And then I can even run a command, pwd, and see if that one works. It does not understand that because it was not a process ID for it. So pldd 456662 is my bash, and it says that cannot open that one because again it's a sudo privilege. So let me become sudo here, sudo su dash, and then I'm going to type in my password. Now I'm root. I can do pldd on process ID 1, which is systemd, and it tells me all the details about systemd shared objects. Similarly, if I want to just get for process 456662, I can do a pldd 456662, my bash, and then I could just get that information. So pldd versus LDD. LDD does it on a file. PLDD does it on a process. Let me go to the next command here. And then if you want to see the man pages, I believe I already went there. You're welcome to just read the manual pages and try some of the examples as well. The next command on the list is Pwdx. This pldd is also was part of the proc file system, because anything that has to do with process, there's a file system on Linux is called /proc. On Unix is also called /proc, but on Linux the environment is a little bit different, and the syntax and things that you do is a little bit different than Unix. Unix and Linux, once you learn one of them, the other one you master it as well. It's not like, it's a lot different. Maybe 20% or 10%, you will see a lot of utilities are different, but the concept and terminologies and how you learn it and how you do programming and how you do scripting, it's all the same. So let's just, the syntax is a little bit different of the commands and parameters that you pass, but that's not a showstopper. So you can always get the manual pages and read it and just try some examples, and you'll learn it easily. If I did it, you can do it too. So let's just do it this way. On the /proc file system, every process has a process ID, and then based on that process ID, the system understands it. So when we do check on this process, like for example, if I just have this process, my bash, if I just start a current shell, I just start the current shell now, my process ID echo $, and $, is the process ID of 959 at the end of it, which is the current shell, as you can see the process ID here for the current shell. So this is the process ID that I'm talking about. And then the PID is important because on the /proc file system, because I created that one, the Unix maintains all the details on that one. So 6959, that process, as you can see, there's a lot of process. Like one of the commands, what is the stat that we were looking at it. When you run the cat of these ones, some of them are binary, some of them are text file. They're all coming because they're pseudo file system from virtual memory. They're 0 initially, but when you're looking at it, it is not 0 byte. It has the details. Like for example, exec will just tell you the path to where and the exec. This current working directory is the Pwdx for it. So when you do this, if I just up arrow here and then just say, I'm sorry, let me just get that one back. And then if I just do a Pwdx on this process, and then just says that it is the start root. And you can see that it is there. The current working directory was also pointing to root here, right here. Current working directory or print Pwdx of it is there. And then the file descriptors is a directory, and then it has a lot of details here. So the proc file system is important. I was just showing you that some of the command like pwdx, and then you could just say pwdx of 1, it will tell you that it started also as root. So if I just start some process from a different directory, then like if, let's say I'm doing a pwd here, and I'm going to do cd to slash my home directory, let's say tilde wlutfi, sorry, cd to home wlutfi. Yeah, so I'm on the home directory. If I run a command like top, and then I run it in the background, then now if I just do a pwdx, that process ID of 456997, it will just tell me that that process is started from this one. Why does it say top? Let me just see if the process is still there or not. Grep minus I top, grep minus v grep. So when you do this, it will show that the top is not running anymore, even though I tried that with ampersand. So let me just rerun it again, top, and then ampersand, and see if the process gets killed. So now it is job number 2. So let's say jobs, and you can see that 2 tops are submitted there, and that, but they are stopped, both of them. So that's why the top was not running here. And then the reason it's not there because of I'm not running a display here. Echo $ display. I'm not in a terminal session, so I have to exit out of here, and now exit out of this one. I am still root. I cannot be root when I'm just using this terminal. So now if I run top here, it will just start the top. So if I just clear the screen and say top and then ampersand with the background, notice that this one starts. Now if I say jobs, it is so slow. It don't allow me to do the stuff. Let me open up this other screen that I already prepared. Let me make sure that I can just open up a terminal here, and that's a normal SSH connection. So with this one, if I just want to run top command, it runs this top, and then if I just say top in the background, now I say ps minus ef grep minus I top, and then grep minus v grep, then it shows that my top commands are running up and there. So then if I do a pwdx of this process ID of top, you can see that it's coming from home wlutfi program C++, because I started from that directory originally. So if I just do a pwdx of this second one, let's see if that one is also from the same directory or from home. Yeah, this one I started from home. So if I go to run from a programs directory, and then run top and then ampersand, and then now I see 3 of them. So this grep minus v is there, but then let's do process pwdx on this one that we just spin it off. I believe last time we did the 80, so let's see the ones that we checked. 20.0, we started for 6, we did it, and then we didn't do this one. So this must be the third one that we started from the programs directory. That's correct. So if I just want to do a kill -9 on this one, now only that one will terminate. But because I forced it with -9, now the other 2s are there. I can do a p kill, process kill, and then the process name is top. Now all of them are killed. and then somehow it did not kill it because I have to do a -F for force or -9, because by default they're doing it -15, which is gracefully terminated. Now they're all killed. So Pwdx will just tell you the print working directory of the executable, where this program executable started. Sometimes for troubleshooting, you need that command in order to just say, well, I started Apache or somebody else started. Was it started from the proper directory? That's why we see two different instances of it running a different behavior, or is the same version that I installed it. So you can check on the configuration if more than one developers are doing at the same time work on the system and nobody's communicating it. You can just remotely log in and take care of the problem and not worry about anything. So here I'm going to, and so the proc file system is very helpful, whether it's pldd, pwd, pmap, PS3, and so on. A lot of the commands are available for you with the proc system. The next command is hostname Ctl. So I'm going to do hostname Ctl. Is very easy command. Hostname Ctl just give you the hostname details. The type, if it is a virtual machine, it will tell you. If it's a physical machine, it will tell you, and so on. The operating system, the version, and everything. And you can get the man page from the hostname Ctl also. Here you can just type in this command. You run it in the server side on my side, and it will give you the same information. So you don't need to have a Linux machine or access to a terminal. All you need, again, is a browser and internet access, and then you start learning here. It's a very intuitive in terms of the examples, the man pages, and then even you click on a button, you just see the output in front of you. So you know what you're doing. It's very easy to learn. And that's why I named the book The Direct Path to Linux Ubuntu, because it tells you like how to learn it with a direct path by examples and by try and error, and then understand it. And then the next one is tar command. Tar command, I already covered it with ganzip and unzip. So tar is very easy. Command and tape archive stands for. We used to do backups, but you can do a lot of stuff with tar. So just as a demo, I'm going to, you can read these ones, and I showed the examples already on the other video with the previous section. Let me just say what I mean by previous section. So on the section where we covered like ganzip, this one, ganzip, tar, pk, ganzip, all of this one, I have one kind of a page that it's going to show everything on with examples like I just showed you, but at the same time I did on this one. So watch video number 3, part 3 of chapter 4, and this video already talked about ganzip, tar, and ganzip. But tar is very easy, so you could just or here you say, let me just make a tarball of just C++ code. So I'm going to say C++.tar, and then I say C++. So now C++.tar code, I have to put a CVF, created verbose files. So now since with filler, it did not happen because C++ itself, let's minus L C++.tar is just already there. So I created, and then tar tvf C++.tar, you can see it is nothing in it. So I'm going to do rm C++.tar. Now this time I'm going to do something other than path that I cannot read right here. The permissions of C++ is there, but I did not have anything with lowercase C++. So it is uppercase C++, and I had to do it with uppercase. So let's just do the same command when we did it for tar. this, and then tar cvf, and then I'm gonna do C++ here. Now this time it created it. Now if you see ls minus ltr, this c++.tar is the file that I created. To look at the content of it, tar tvf, and then C++ and .tar. And I could also do xvf to just untar it, but watch the other video because I had more examples of it. I don't want to repeat myself on this video again and again when we can just do it. But just before demonstration purpose, let me repeat myself one more time. Sorry. Because it's for my job is to teach you, not to just say, well, there's another video, just watch that. So let me just go to the tar. So now I did the tar, I make a directory called T, and cd to the T, and then I say tar, I'm going to go one directory up. I'm going to put xvf, saying extracted verbosely from the file to the parent directory, and I named it C++.tar, but I'm going to extract it here. So now the C++ is there, and then everything that the content of C++ files are there. Since I don't need this file, I can even gunzip it, but the job of this tar is to just do it. So now I can just do rm minus rf and t and C++.tar, and then now I get rid of those two files that I just created, and we're done with the tar command. So let's go to the next command, ldd. The ldd command is showing you the dynamic link library of these files, and I'm showing you here for the GCC binaries, and then here's this one, and then if you're looking for the verbosely, and then this one give you more details of the shared object files, and then as well as -d options, which is showing you to do, what is the -d in this case? I forgot the -d. So let's say you forgot the -d option, and then you can do a man ldd and search, look for the -d option, and it will tell you exactly what -d does. So this one will just come up here, and if that -d here is right here, it says data-relocate. So every relocatable object is which is with the ELF, and then you do the -d option. And then the next command is strace. Strace is just to trace equivalent to Solaris trace command. Strace pwd. So I run the pwd command. It just tells me this output. But if I do a strace pwd, it will just show all the system files. So you can also do a strace on a running process to just check the statistics of what's happening at the current moment, and that way you can troubleshoot it. Strace is like a trace command in Solaris. It's a very useful command, and so man strace will give you a lot of functionality in command lines. And here on the web also, I must have done some stuff for you that will show you, like strace pwd and other examples you can see. I did a lot of it, but a lot of it you can also do at the runtime at command line. Like for example, let's say you do ls-l, and then you say strace ls-l. That will just show you before it runs. And sometimes you can, I'm doing this one to trace programs that are hanging or in some state that is unknown to other users. Then I look at trace all these function calls, read, write, stat, and file descriptors, the number of file descriptors that are open, and everything else. Based on that one, you can debug the code to see where it is having issue. So let's go to the next one, core. I may make a video separate for some of these ones because there's a lot to cover on one small session. So this is just to find out the core files. Sometimes core file gets created and you just do a find command and delete it. Core files are just sometimes when the system hangs or core dumps, and then it will create a segmentation fault or something. And you have to have a lot of knowledge of the system, as well as debugging tools like ADB, GDB, and MDB, and so on. You can do it. And so here I'm also covering ADB for Advanced Debugger. This is on Solaris machine. On the Linux, you have Module Debugger as well as ADB as well as GDB, GNU Debugger. With GNU Debugger, you can also do it. And this is like when you do a -K, you could do the live kernel and debugging. So read these man pages and understand them. And there's a lot of example I did there because I had to do at some points a lot of troubleshooting of systems. GCC is the GNU C compiler collection, and I'm showing you here examples of it. It's really good. So like here I wrote cat hello world.c, and then here's the main, and then we compile it with GCC. If you don't give it any argument with -o or anything, it will just create the a.out. But if you want to create it with -o, you just give it the file name that you want to create it. Similarly, GCC is for C++, and GCC is, I'm sorry, G++ is for C++, and GCC is for C. So you can, as you can see, all of these examples, I did it. And I might have here under the programs here, like C, and then you can see cat -n hello.c. If I just say GCC hello.c, it will just create a.out, and then a.out is now executable. It will just /a.out, and then you could run it and just get it there. If I just say GCC -o hello.c, and I want to just give it as name of H for hello word and W, and then hello.c, now I just created the hello word.c. So then I could just run it hello word like that. And then if I say file hello world there, you can see it's an executable link object. Similarly, file hello is a executable link object, 64-bit. And then LDD of hello is the same as LDD of HW. So this is what those commands are. And then man GCC basically tells you for the C compiler, and C++ compilers, actually it's the GNU C, and G++ is the one for C compiler. So if you just say --version, you could see it, or -v. I'll just tell you that this. So G++ or GCC. GCC is the C, and then you could see that it's a version, and then --version will also give you that same information. Let's see what's the next one. So GCC swapon. Swapon and swap off is basically when you're creating swap files on Linux, you have swap there, and then you have to be root to let the swap on there to turn it on. So man swap on, swap off, you can see it is for basically swap file system. The swap file system was just kind of a helper for the memory. When you run out of free memory, like if you see free -h here, you see that I have 15 gigabytes of memory, and then the swap -l will just tell me if I have a swap installed. Once you do a swap, like if you are root and you say swap on -s or -l, you will just get those details here for the swaps that are there. But swap on -l will not give you much, but free -h will tell you. And then on the buffer size, everything that is on the swap is 4 gig is there, and then 4 gig is free. So when you run out of physical memory, swap takes effect and then uses your hard disk to swap some files here. And also when you run the top command, and then you can see the swap partition, and that is 4 gig, and 4 gig is available. Similarly to that one. Also, you can do uptime, and you could see the load average and everything here. HTOP, if you're running a graphical interface, is a little bit better than top, but that would be a different topic. I want to just cover all of these ones separately. I hope you enjoyed this session because we covered everything on this row. And the next one would be the GDB, talking about GNU Debugger. So with GNU Debugger, I will give some examples of GCC as well with C++ code and everything else, and write some C or C++ code as well. And please don't forget to subscribe at our channel so you get the latest and all the updates. Love and peace for all. I hope you all enjoyed it. Take care. Have a nice evening. Good night.